Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. Welcome back to my Create an RPG series. Now, this episode will be a little bit different from the other ones so far. We had a viewer that came with a very prudent and good point, which is we should be commenting our functionality so that it is easier to come back to it later on and then understand what's actually going on. And since I'm all about trying to teach good habits and good naming conventions and consistency and such, that of course makes a whole lot of sense. So what we're going to be doing in this episode is we will only be going through our code and we will be commenting different sections. So if you want to have a refresher a little bit about what different things do and have commented code put up, then this might be a good episode to follow along with. However, we will only be adding code and talking a little bit about what different things do. Adding comments to the code and talking about what things do. So if you're not interested in that part, we will not be adding any functionality. So you can completely skip this episode if you want to. This is just for cleaning and making the project better, essentially, moving forward when you want to take this to its own level where you want to bring it to how you want to develop on your project further, or if you want to export certain parts of the functionality, maybe you want to have the commented code so that you remember what things do in case you have forgotten. So yeah, that's the whole preface for this whole thing. So if you want to follow along, we'll start with that. If you want to skip, it's perfectly fine, and I'll see you in the next episode. But let's get started. So let's close down all of our different tabs if we have any, and let's just start from the top. So BP ability, what functionality do we have here? Well, let's go to the event graph first and see what we have here. So we have in some cases we have, in most cases we've tried to have functions that have self-explanatory names to them. So we won't be like adding a function saying like, or a comment saying like this is where we attempt to use an ability, because that's what the function says, right? And in this case, can use ability sort of explains itself. It determines if we can use the ability and usability pre-step and stuff like that. So we'll try to clean up the more obscure parts of the code, make sure that they're a little bit clearer. So let's start from the first function here, or the first event in this case. So we have a can use ability. Let's check what it has. So here it has the final use allowance check. We can say that we can comment this and say that this is supposed to be custom checks to allow using ability. Essentially meaning, and again, you don't have to have put the same comments as me. If you have something else that you think describes it better, then feel free to do so. But essentially this was meant to be a function that you can overload in a child on an ability and say if you want to have a check like do we have enough mana for this ability, or do we have, because we have checks currently here which checks if a tag is preventing us or if a tag allows us to use an ability and stuff like that, which is built into the ability itself. But this is meant to be anything else that you may want to check against and make sure that it's actually allowed to be. It could be like anything from is it in a proper area of the map, is it during a cutscene or whatever, and you haven't like the cutscene is sort of like semi interactive, so you can actually move around, but you maybe don't want to have the character allowed to use abilities or stuff, only moving around is allowed and things. So that's what this is. This one we can comment, I guess, and say check if tags prevent using ability. And that's what that function does. And this one, Over here is using ability prerequisites fulfilled. We can add a comment anyway, I guess, and say make sure we have all required tags to use ability. So it's just a little bit more descriptive than this, even though I feel that this is pretty well describing. Inside of this one should be blank, yes. This one over here, all we do is we're just getting the active tag container and checking against the prevention tags. I feel that this is self-explanatory in conjunction with this comment. However, you might not see it from this perspective of checking tags to prevent using ability. So maybe for that sense, you might want to also encapsulate this whole thing here with the same comment, essentially. And we might need to do the same thing over here. Like so. So make sure we have all the required tags to use ability. Okay. So this should cover more or less everything in this part, I would say, of the can I use ability. This one just calls on the pre-step. And the pre-step we can call a step before using ability for things like adding tags or other pre-ability functionality. So here we can essentially put anything that we want to have, that we want to happen before the usability actually triggers. That's the entire purpose here, and in this case we're using it to add our ability tags. The add ability tags to our character. In this case it's over here. Let's comment this and say add tags to gameplay component to describe properties affected, essentially. So if we're burning and things like that. That should hopefully be sufficient here. Going back, we have the call to our usability, which will be getting our mesh, we'll checking if it's valid, and then we're running a montage, and then we're ending the ability. So here we can essentially say something like this. Play montage if applicable. Because that is essentially everything that we're doing here, right? Because we're just checking if we can get a mesh to see if we have an montage, to see if we can play the montage, and then we're done with ability, essentially. And our end step is, let's do it like this, a comment and say, undo everything that we feel should be undone. That was done in the ability. Now, maybe not the best description, but essentially in this case the only thing that we have implemented here is we have a pre-step where we add tags. We also want to remove them to like get back to status quo. You might have abilities where not everything is supposed to be undone, then you wouldn't have this part, of course. Then you might have other things like at the end of an ability something should happen as well, and then this comment of course is not valid anymore, but then you would add your code here and say like, okay, maybe now we give this character a certain buff or something like that. And yeah, so you have to update your code to reflect, of course, what you're doing with it. And that's going to be necessary whenever you refactor your functionality or when you're adding your functionality to what you have already done. Anyway, that's more or less the event graph, I would say. In addition to that, we can go into our functions. So here we have already commented. Here we have commented, can use ability. We have commented a bit. Add ability, we have commented. Final use check. This one, actually we should probably do this one as well, because so here in our can use ability we chose to have this comment. So let's go in here and make sure that we have that comment here as well. Yeah, so remove tags ability. Here we just comment this and say remove tags that were added at the start of the ability. Okay, and that's pretty much it. In addition to that, you could also, if you wanted to, have extra information on your different variables. If you want to explain them further, you could have tooltips for them. You could put them in categories to make sure that they're organized in a way that makes sense for you. For me, I feel like these variables are sufficient, so I will just leave them as is. So with that done, we can close down our ability, I think. And our abilities that inherit from this, the multi-slash and the slash, we don't really need to comment because they have the comments from their parent in those related parts. In additional parts that you add, you can add comments, of course, but in my cases, these are just being driven. They're completely blank blueprints. We only have changed the properties of the ability itself, which is handled then in the base class, essentially. So let's open up the BPC ability component and see what we have here. Going to the event graph, let's start off here. You can see the only thing we have here is we're saving, might want to do it like this, we're just saving pawn reference for later use, like so. And that is the only event that we have, I think, yes. So let's go to our functions. Here we have adding an ability by class. So here we can say, let's mark, let's do it this way. Create and add ability from input. So the class that we're sending in here, we're spawning it and we're adding it to our available abilities array. And then after that, we are saying over here, inform that abilities were updated. So anyone who is interested in knowing their abilities, in this case we have the user interface, they will get informed here. Going to usability, we don't have a whole lot of code here. It's called usability and we're attempting to use it, and that I think is fine here. Initialize abilities, this is just a function to initialize, holy moly, initialize our abilities from an input array. That was way more difficult than it should have been. Yeah, so that's it, and that's all the functions and events we have here except for the variables, and I feel that these are pretty self-explanatory themselves as well. So we'll close this one down, and now we're done with abilities folder. Going to the AI folder, we don't have a whole lot here done, but let's start with our on-created tasks. And here we can say in this case here, get a random ability available and use it. That is what we're doing here. And we can close that task down. Let's open the find roam location. Here we can say find a random point in a radius and set that as our roaming destination. can close that one down, open the AI state change, and the only thing this one does is, of course, we send BPI message to change state of the AI. Here we can actually be a little bit more descriptive. In this case, we know exactly what they are, so we can give some examples maybe. Roam, attacking, etc. We only have two states currently, so etc. will represent everything that we possibly add in the future, or you add in the future, like so. Yeah, and then we can close that one down. And behavior trees, actually, can you comment? You can comment. Let's see, do we want to comment? Here it sort of makes sense to actually rename the node here, saying roaming behavior, and have, oh, that's not how you spell that, behavior. So here the actual sequence here describes essentially what's happening, so we don't have to have a comment here, I feel. In this case, we can, however, put the comments, because this one is not as clear. Actually, we can make use of this sequence as well and say target found, change AI state, because that's what we're doing here. We're determining that player target has been set, and we're changing a state to be in attacking mode. So if you want to have it in comments here, of course, go ahead and do so. For me, I feel it becomes a little bit more clear if the actual parts themselves describe what they're doing. So this is like roaming, what do we even call this? We'll just call it roaming, I think. So this is the actual roaming behavior, and this is the starting to go into attack mode. We'll save that, close it down, we'll go into our attacking. In here we can say this one is the top node, we'll call this one attacking then to be consistent with the other one. Like so. Here we can say target lost, change AI state. And over here we are saying, let's call this one attacking behavior. So this is what the actual attack behavior is, and this is the general one. And again, you can have this slightly different if you want to, but yeah. We will also be coming back to this a little bit in the later in the episodes, so we will be expanding this as we go along as well. Moving on, we have our blueprint interface now here. And in this one, we don't really have much. We have one function that is changing that's interesting. I didn't know that you can add comments, but you can't remove comments. Okay, well that's sort of interesting. Having good function names here that are descriptive enough, and also the inputs and outputs being descriptive enough, is good, because you don't actually have an implementation in your interfaces, right? So it's good enough. But yeah, what is this? Show bubble one. Okay. Anyway, so we'll close that one down and just pretend like I didn't do that blunder of adding that comment. We go to our AI controller, and here we have our begin play. And what we're doing here is essentially set start AI state. That's what this essentially is doing. And here we have change state based on input. Let's actually do it to change AI state based on input. That's all the code that we have in here as well. So we'll exit out from here. We go to our AI character. Our AI character has a little bit more of code, and this is a little bit messy, I guess. But what we can do is determined that the player should no longer be followed. We lost line, let's do LOS as in line of sight, for too long. And then we'll move that away a little bit. And here we will say comment, and we'll say we lost, or we, AI lost line of sight. Start timer to reflect how long we will be in aggro, meaning we're aggressive towards him and following him. And up here we have the situation of we have actually had a sensory updated where we have found the player target. So here is we just found or saw the player target. Store the value in our blackboard. Like so. And that, I believe, is all that we have in this one. We have no other events, no ticks, no overlaps. We have the begin play parent. Everything is fine here, I think. We can move this down maybe. So we can close that one out. And in our blackboard, it just consists of values. We can't really do that much there. Let's go to our animations. Here we don't have a lot of in the ways of commenting. Going to our attributes, we open up our blueprint component for attributes. We go to our event graph. And we see that we don't have a whole lot. This is just our placeholder dummy to allow creating new event dispatchers. Let's see how there we go. I wasn't sure if I had removed too many characters behind the note. New event dispatchers using this signature interface. Like so. And then we can go to our different private and public functions. Begin place there, it's empty. Okay, good. Change attribute value. So this one might be a bit messy. Let's see here. We're changing let's do a comment over here, because now I'm going to be describing all this mismatch might be a little bit even more messy if we add comments around these different parts, unless you like really clean this up well, of course. So here I'm gonna add a comment over here that describes the whole function essentially. So changes an attribute type, example given base value. Let's actually enlarge this a little bit so it's easier to see what I'm actually writing. By the value change and then setting corresponding new value in the structure which is passed as a reference. So even though it might not be obvious right here when we're looking at it, this is a pass by reference, so having it in the comments might make it easier to see what is going on here essentially. And then going to this one, we can say that here creating a context structure for later use. That is not how you spell structure. Going to the next function, get attribute from tag. What we do here is, and again, this will be messier the more we build it out. So I'll put the description in the beginning here saying that determine which attribute we want information about. Come on, you can do it. Come on. Okay, well, that's fine, I guess. That'll be okay. Because this part we're determining the attribute and then we're setting it as a local attribute and then we're just returning it. Let's go into the macro here and say matches the input tag against values to create execution pins based on needed functionality. So what I mean by this is what we're doing here is we're essentially checking against specific tags in this case. In this case, we only have the health tag so far created, but we could have mana tags and speed tags and whatever. And the reason we have this is so we can create a output here which gives us execution pins so that we can use them later on when we're doing things like let's see here, change attribute. When we want to do that, we create an execution pin here so we can actually affect that new attribute out here, which also allows us to call on event dispatchers. So what we're essentially doing is providing a flow available for us to do this kind of logic for. So that is what the purpose of the macro is, and it's being used in, I think we have it in 2 different places. So get attribute from tag, we have it here to determine which structure we want to find. And again, the execution pin allows us to do that. And here is for the changing. And over here we have it again to just see which kind of event dispatcher we want to bind to. So all 3 of these different public ones, you make use of this macro essentially. Let's see, did we, so that is what we had in here. So hopefully that makes sense. If you want to frame it differently, do so. Change attribute. We'll put the comment here and say change the value of an attribute based on inputs. This is sort of self-descriptive in the name, I think, but if you want to add something further here. And here we do the actual changing of the value. Here we create a context, which I think is self-explanatory because that's what it's called. And here we're updating with an event dispatcher. So inform anyone interested our attribute has changed. Now, this might not be the best thing to put this comment here because as we add more and more stats, we'll get more and more code downwards here, which means that we may have to like encapsulate it further down to make it encompass everything to make sense. But yeah, those will be later problems, I guess. So you can make a decision later on if you want to change something. At least now you have the functionality or the information here that you need. Add attribute listeners. We will just say here that given a specific tag, create an event dispatcher connection to the event being sent in. Because remember here, what we're doing here is we're saying we want a listener, and you're saying a specific tag here should be hooked up with this event, and this event here is following backwards. So the binding here goes to whatever the event we put into the call of this attribute listener in our different parts of our code. Yeah, that's everything in this component, I think. So I think we're done here. And here we only have structures and things. Going to our characters, we should go to our third person character because it probably has the most stuff in it. Let's do this. We'll drag all of the begin play stuff out and say on that also we should get controller from pawn and hook that up here as well. No, this one's a player controller. Okay, and this is not necessarily going to be a player controller, it will be an AI also. We should probably do a cast here. This is fine since it's only happening once in the begin play, but cast to player controller, and we'll say if it succeeds, we should go in there and we should send in, well, this reference essentially, and we add it to the viewport. So add HUD. Let's see if we can move these out. And if we fail that, we want to still do all of this stuff, because this is things that the AI doesn't have a player controller, but it still wants to have its abilities like we gave it. So we need to have both of these rejoining here. And here we just say, give ourselves some space for our comments. Set up starting abilities, and here we are super obvious, I think, but let's be good and say equip weapon class, and over here we are just setting a set characters animation for locomotion using this blend space. That's what we're doing there. When it comes to our keys here, everything here is debugging information. So I don't think we should comment any of this, because all of this will be removed at some point later. We're just doing this to check our functionality, that it works as we're developing, to make sure that if we run into an issue, you will find it at an earlier episode rather than a later one, and then you don't know at which point something broke, essentially. So this is probably all we need here. We have also an interface for getMesh, which is just return the skeletal mesh representing the character. Like so, because that is what we are returning whenever someone calls on this function. And then we have the rest of our abilities, or rest of our variables here, and they are self-explanatory, I think, so we will leave those. Going into our mage, we don't have any logic in this one at all. Going back to our warrior, we have no information here either. And then we have just skeletons and physical animation, physical assets and such, and also meshes. So nothing more needs to be done here. Let's go to our combat blueprint. So this is our component from combat. And here, let's see, where do we start? Let's start from the top. So listening in on the pawns, owning pawns, no, actually not even pawn, owning actor being damaged, then apply that information to change attributes, because that's what we're doing here. We're checking what kind of damage are we getting, and then we change the health attribute here based on that damage. On our begin play, we're setting up some listeners for some things. So let's do this. We'll say this one here. We'll say add listener to melee weapons. That's not how we spell melee. Weapon attacks. Let's do that like so. And then we also have here we're actually binding this part here. So really want to hook this up together so that it's the same thing. So bind damage taken to react to. Let's have a comma there so it's a little bit clearer. So here we're binding the damage taken event, the any damage taken event technically, to react to, and this is how we react. And here we just save pawn reference for later use. Here we have whenever we are affected by someone doing a melee attack, we go here and we say check if we are currently attacking with melee weapon. And then we have two situations, because let's also update this a little bit and say attacking with melee tag changed, check if we are currently attacking, because we get this whenever it is removed or added, remember? So if it has been added, we say start checking for damaged actors. And here we say stop checking for damaged actors. And in the case here, we say to check for damaged actors, activate tick and let it scan. Then here we'll say no longer attacking, deactivate tick. Then on our tick we have this part where we get weapons attack areas. Essentially what it's doing, it's giving us a bunch of different 2 points so that we can compare. And in this case we're saying line trace each set of points and get hit actors. We'll give our comments a little bit more space so they don't get crowded. And among the actors, among hit actors, attempt to apply damage. Next part is, let's move this a little bit out of the way. Here, attempt damage. And here we just say this part I would comment, I guess. Make sure we have not damaged this actor before in the same damage window. because we only allowed to damage them once, remember? And the place where we clear that up is over here currently, so we'll expand this a little bit so we can have a comment in a comment, so commentception. Clear previously injured, no, let's call them damaged actors, so we can damage them again. That sounds very sadistic, but that is essentially what we're doing. Like so. Okay, and also if you want to organize things a little bit further, you can also right click, I think, no, double click on it, no, oh, here it is, comment color. You can set different comment colors for comments if you want to have them grouped in a certain way, so blue means one thing and red means another thing, so it's easy to see when you're scrolled out and have a lot of comments. You can see like, these are red areas, that's what I'm looking for and such. I don't have such a system structured, so I don't currently have that kind of color coordination, so I will just keep them all white for now. And here we're just so here we say we can do it like this. We'll just say here new actor found, add to array and damage, which actually might then be prudent to include this one over here as well. So we might even want to do something like that. Okay, and over here we have we equip a weapon. So we spawn a weapon and we set it as our equipped weapon, and we get a mesh and we attach it. So I feel it's sort of self-explanatory, but let's put a comment around it. So spawn a weapon of input class, then set it to our currently equipped weapon, and also attach it to a, in this case we're attaching it to a socket, but you might not do that. You might have some different kind of logic here if you want to, but yeah, then you will change the comment to reflect that. So that's good. Now we've done everything in the event graph. We don't have any functions here, and we only have some variables, which again I feel are pretty self-explanatory, so we will leave that for now. Let's go to our function library. So this is just a function library that returns a value. Returns a calculation of a structure of an attributes, different attribute types for a final value, I guess. Because this is like with multiplications and stuff like that, it will be whatever value you have, like your current hit points or your strength with all of its modifiers, or whatever it might be. Essentially, that's what we're calculating here. Gameplay tags, let's go to this, and this is our properties. Remember, this is a little bit fuzzy, of course, because properties, what do you mean by that? And it can be used in so many ways, and we have seen some already, but we will be delving into this more as well later on. So again, this is just our placeholder dummy to allow signature copy for event dispatchers. Like so. Okay, and let's start with our events here. So we have our event begin place, doesn't say anything, and then this, then we go to our functions. We have the add tag. So here we add one stack of the tag. Add our property tag to our container, or let's not say container, let's be descriptive. Let's say to our active tags container. And then we have, this is debug information essentially. Debug info print tags. You might want to remove that at some point also, or either that or deactivate it so you can make use of it later if you have like problems with something. And here we notify tag has been changed, which could be either that it's added or removed, right? In this case, it's always added, but it will also be the same for when it's removed. So we'll just say changed here to be consistent. Going into the add stack, we can say, let's just have exactly the same comment in here for the whole thing. And then this one, add property tag to our, well, we can't go into this one. This is a tag node, so it's only available in C++, so we can't actually go in and comment that further. This one, let's comment this one, I guess. Like so. And then we go to this part, notify that tag has been changed. And here again, it could be a little bit messy, so we'll put one here in the beginning. Like so. Okay, so that's all of those different parts. So let's go to our remove tag. Remove one stack of the tag. And here we there we go. It's like so. This is the case where all stacks are gone. So if we only had one stack and we removed one, we're at 0. At that point, we also make sure to remove it from the container, which we don't do otherwise, because then we at least have one or more stacks still left. So check if we have run out of stacks of this tag. If so, remove from the active tags container as well. So, and then we have our debug info again here. Debug info print tags. And then we have here again this one, notify that tag has changed. So in this one we already have it commented because we added it from the other add tag part, and same with the print here, we also had that one there. This one we can't comment because it's C++, and this one is remove tag. We have not done this one, so we'll say remove one stack of the tag as its main comment. However, this code might need a little bit more explaining. So we remove a tag, one tag here, clamp value between 0 to 999 in this case. You might have different values. And let's see, let's get all of this and move it a little bit. Update tag stack amount. No stacks remain. At least one stack remain. There, and then we can check get active tag container. So this one just returns active tag container for those that are interested in that information. Add stack, commented, remove stack commented. Actually, yeah, this is outside of things, but it should be clear enough with all the comments, I think. Remove stack, print amount, add tag listener, add a listener for the input tag to the input event. And notify tag change, we have commented, create context, create a gameplay context for later use. Well, not entirely true. It's being used pretty much exactly after this, but yeah. And determine tag change. This one determines which execution path should be used based on input tag. Like so. And that's all the code that we have here. So we can close out the gameplay. Let's save everything to make sure that we don't lose any information in case the engine crashes or anything. Gameplay context is a structure interface. We can't comment, as we learned earlier, and I would never do something stupid like that. Game mode, we don't make use of that much. Notify, here we might want to comment some things. So let's start with the notify begin, and here we will say here I want it smaller. There we go. Get a game play tag, gameplay, get a gameplay component to add properties to. And then what we do here is we add damage window active, inform melee attack is going on. Because remember, this is a notify state. This is what we specify on our animations. So this is the beginning of the animation where we determine a damage window is supposed to be. So we might want to say over here that damage window is now active. Move it a little bit to the side. So with the beginning over here, we are having a damage window that's active, and then what we do as a consequence of that. And then over here on the notify end, we are actually, the damage window has stopped. So damage window has ended. And then we do the same thing. We get a get gameplay component to remove property tag. So, and here we say no longer attacking with melee weapon, which is technically not true because we're still attacking with it. It's just that we're not having a damage window anymore, but it should make sense, I think. So we're done with our notify. Let's go to our status effects. So the status effect base class, we have here where we are attempting to add a status effect. And here we check if it is allowed or not. Check if we can add status effects. Let's move this one out. And if it is true, we can start status effect. If we cannot, then we end. So cannot add status effect, attempt early end. I'll give this a little bit more space. Let's go into that function or that macro and see what we do. We check if we have, let's do this, attempt to end status effect early. And here we want to get status effect component and remove if possible. And then here we're just saying which outcome did we get. Because we can either have removed it, which is when we find the status effect component and remove it, or else we didn't have the component and we'll say unable. So that's essentially it. In this one, check start conditions. We check, essentially we do this. We check if we can add a status effect by checking if it has its tags and none of the prevent tags. If you want to clarify this further, it's up to you. I feel like these describe pretty much well what they're doing. Yeah, so moving on, we have our status effect, which is actually when it's starting to work. So apply status effect tags. Apply changes to attributes from the status effects. These comments do take up a lot of space, or maybe I'm writing too verbosely, I'm not entirely sure. Over here we set up the start the periodic timer. So for things like poison ticks, for example. And over here we set the start the duration timer, the life time of the status effect. So how long the status effect is going to be alive. And applying its functions. So this one is, that's not what I wanted to do. Events to overwrite functionality for periodic effects in child classes. And over here we have the end of the status effect, so we now remove all status effect tags that we applied earlier in the beginning. And then we comment over here and we say remove all changes to attributes from status effects. Here we say clear all timer handles, duration and periodic in this case. And here it kind of becomes bad now that I chose to name this one attempt to end status effect early. That's not true. Attempt to end status effect is going to be more accurate because we're actually using this as both in the start or in the normal end here. So that's better. And clear timers, we can essentially copy the comment here because this one is not very complex. Like so. And inside of here, apply attribute effects. This is where we add and remove depending on the boolean. So we'll just do comment here saying add or remove attribute effects from the status effects config, let's say. And this one just determines add or remove. And then we're going through and checking if we can get, do we have a attribute component? And if we do, we go through all attributes to change and apply change, like so. That's essentially what this is doing, because we're looping on them. It's possibly that this one should be included here as well, but that's fine, I think. And yeah, so let's see here. Begin play, we have commented everything here. Remove tags, we have not commented. Let's take this comment in here and go in here. This one seems straightforward. Just looping through and removing everything, so that's fine. There we go. Let's see if we have actually commented everything now then. So we have our functions, we have our clear timers, check tag, add tags is not being commented yet, so we'll do this one. And comment. So apply status effect tags. Let's see. So that was this one, and then we have remove tags, and we have apply attribute effects, which is all of that. Yeah. So we have this macro also, and that one is done as well. That should be good. Let's close this down. Okay. Let's save again. Okay. Let's see here. This is a child class, and here we have our blueprint component. Let's go to the event. Let's comment this and say placeholder dummy to be able to copy signature for event dispatchers. So, and we don't have any other events here. Get status effects. Turns status effects currently applied. Add status effects, just add a status effect to array. Notify everyone that status effect was added. Make this a little bit smaller on the side and then a little bit larger. And over here we will say attempt, call the status effects attempt application code. So that's the one that starts the whole chain of the status effect of checking if it is allowed to be added and stuff like that. And remove status effects. Removes status effect from array. And notify that status effect was removed. Pretty good. And since these are so clean and they have so little code, we're done here with this blueprint component as well. We'll save again. We'll go into our weapons because now we're done in that folder. So BP Sword is our child class of BP Weapon. So BP Weapon, we don't have any code in, we just have our weapon. Maybe you want to have some functionality in this, like a comment that's just saying like this is a base class, it doesn't do anything, and that the meshes themselves hold these different points or something like that. Because if we are get damage locations, did we not do that in the base class? We did not. Well, that wasn't great. Okay. We are inheriting it. Okay, so it was added properly. So we have the interface from inheritance, and this is just how it looks like here. So in the BP weapon here, interface, yeah, it's not implemented. We don't have anything in the base class here. So it's all fine. So you can maybe say, should return all sets of points that should scan for damage. Skeletal mesh determines the points. Let's say skeletal mesh of the weapon. Like so. Because remember, if we open up our sword, go to our skeletal mesh for that. Over here, you can see that we have added an A and a B point here, which represents the hilt and the edge, and that's where we're doing the trace from, remember? So that's why this one is returning that simple point, but if we were to have multiples on our weapon, then it would return multiples and create an array of that and return. Base class doesn't have anything, we just put the comment here. Going back to weapons, we have our interface and our structure. Going back to our widgets. Our widgets are not very advanced, I would say. Let's comment them anyway. So this one is for abilities. So we say here, abilities changed, clean up arrays. Then we let's do, actually all of this is the same. So this one here does it loops through all abilities, creates widgets and adds to the box. And here's the construct, which is saying that it's listening to listen to changes of abilities. And that's when this kicks in, of course. So that's our abilities widget. The one with an S, the plural, so like all of them. This one just sets graphical information. That's all the code in that one. In health, this one will be a little bit more advanced, but not much. Listen for health changes. And then update health once at start to make sure it starts with a correct value. And this one just says updates widgets to display health in progress bar. Okay, going to our HUD. We don't have any code in the HUD at all. Going to our status effect, we have This one is for the singular status effect, so this one will be the one with all the graphical information. So set up graphical representation. Because it's just taking icons and things like that. The plural status effect is the one that actually does some code. So we have here where we listen to status effects added, and this one is listen to status effect removed, and this one just creates and adds status effects to box. And this one finds and removes status effect. Then we have the XP, which is probably one of our uglier ones, but the functionality is cool. Update that level has increased, or rather changed, because technically that's what it has done. And this one updates that XP has changed. And this one, just like the others, just have listeners. So listen for level up events. And this one, listen for XP changes. Actually, we shouldn't say level up, level changes. Like so. Then we close that down. And I do believe we still have one. Okay, so our XP blueprint component. Okay, so first we start off over here. Placeholder dummy for easy copying of signature for event dispatchers. So, and what we're doing here is we are getting some XP and we're adding it to our current XP, and then we try to level up and call anyone that inform that XP has changed. Adds an XP amounts and tries to level up if possible. Right, and try to level up here. Let's see what we do in here. We are checking check if we surpassed a level up. Over here we can say we did not level up. And over here we can say we did level up. Inform that we leveled up. That's a little bit too many else, I do believe. And then we call on ourselves again over here. Call on ourselves recursively to see if we have multiple level ups. Recursively. There should be an E there at least. Like so. And that's pretty much all there is to that. Let's see, level up here, what we do. We check if That's not what I wanted. Okay, let's do it like this. We'll drag it up here. So the comment will say, check if we are max level already. Check if we are above XP requirement for next level according to curve. And then we can see we didn't level up, or we don't level up because we are at max level, so we are already level up. And here we are leveled up. Okay, let's see. So level up is commented, try to level up is commented, event graph, begin play. We add is listen if owner dies. Like so. And if we do die, we check, or dead state changed. So if we are dead, check if we are dead. Over here, we are dead, award XP to our killer. Like so. And then award XP is over here where we're sending in the XP and they're trying to level up. That one is self-descriptive, I believe. We don't need comments there. And that should be all of that. So yes, I do finally believe that we are done. So let's save everything so we don't lose anything. And that was a bit of a longer episode, but hopefully it was useful for those of you that are interested in maybe reacquainting yourself a little bit with all that we have done, and also getting your code a little bit more structured so it's easier to build upon it later for you as well. Anyway, hope to see you in the next episode. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.